Okay, welcome to yet another session on network design and administration. I'm expecting that whoever is enrolled in this course is a student taking DIT SEM 4 and the DCS SEM 4. Well, if you have had a look at the previous notes that I've shared, I started by sharing a presentation on introduction to networks, and the other presentation that I shared was on network topologies. So I'm aware that most of you have come across this. On network topologies, I'm sure in one of them came across topologies such as bus topology, mesh topology, star topology, and and ring topology. Okay, so this is just yet another continuation of that. But I would want you to, this particular session that I'm having right now is not necessarily a full lecture. The session that I'm having this time round is to give you instructions on what I expect you to do before we meet in the following session. Now, if you look at the topic 3 lecture notes, I have shared some notes about, the notes are under, the title of the notes are Community College LAN Design Consideration. So that is if you open the PDF document, that will be the topic of those lecture notes, Community College LAN Design Considerations. So that is a document that I have extracted from Cisco website, and it is a guide. It is a guide to organizations on how to design their local area networks. We understand that networks are everywhere, and nowadays it's almost impossible to avoid having a network within any business organization. So you can think of any other organization, could be it a school, a hospital, an office, a government facility. All the time, in all those locations, you are likely to go and find that there's a computer network that has been installed. Now, when it comes to designing these computer networks, there's usually an issue with regard to availability, because when you look at any principle of network design and security, we can summarize all the principles into 3 main objectives, or 3 major objectives of having a network. When you're creating a network, you intend to achieve what is referred to as the CIA. So you intend to achieve what we are calling the CIA. So CIA is an acronym for C is confidentiality. When you're designing a network, you do want your network to be confidential. Confidentiality in this is something to do with the privacy of information. You do not want or do not wish to have a network that is being hacked, or do not want to have a network that when you send a message over the network, it can be intercepted by some middle devices in between the network architecture. So you want to achieve confidentiality, meaning that a message sent from one computing device to another computing device must arrive safely and securely. So that is one major objective of any particular network, and they are also borrowed into network security, that you want to achieve confidentiality. That is C. Number two is the integrity. The I is for integrity. And for integrity, what we mean is that whatever is being transmitted through the network, in addition to being confidential, you'd also want it to be consistent in the same way it was sent. You do not want to send maybe the letters A, B, C, D through the network, and whatever is being received on the other end are E, F, G, H. You'd expect that a message that is sent from one device to the other to arrive in the same form that it was sent. And that is what we mean by integrity. So it's something to do with the consistency of a message. I don't want to look at it from the point of hacking. I want to look at it from the point of, because hacking can be covered under the first principle of confidentiality. I want to look it from the perspective of errors of transmission, because you're seated in front of a computer, you want to send a message over the network, and you expect that the other device is able to receive those packets in the same way they were sent. So do not want to have lost packets along the transmission channel just because probably there were issues with your connectivity media. So again, if you look at the previous notes that I shared, under the topologies, I also mentioned something to do with the network cables. And there are different types of network cables that can be used to connect machines to a network. So in that case, they are called the connection media. We do not want to say they are called the network cables. They're just called connection media, because the connection media can either be wired or it can also be wireless. So when it comes to wireless media, we have the different wireless technologies that can be used. And when it comes to wired media, we also have the different types of wires or cables that can be used to connect two devices together. Now, there are usually problems with either faulty cables. There are usually problems with maybe the protocol that is being used. And in some cases, you might end up or even faulty network cards. And some of these problems might lead to errors in transmission. Because one thing that we need to understand is that when you are typing a message on your screen, I want to assume you are sending an email. When you type that email and you click on send, you are actually interacting with a very top layer that is called the application layer. So in the later lectures to come, we'll be looking at the different models of communication that you can find in networks. And the major models that we have are, one is called the TCP/IP model, and the other model is called the OSI reference model. So we'll come to those two major topics and we'll look at what is the TCP/IP model. So for your information, TCP/IP is just transmission control protocol, internet protocol. So it's all about protocols, and a protocol is just a set of rules that govern transmission of data over the network. So that is TCP/IP, transmission control protocol / internet protocol, and it is a protocol that is used widely over the internet. And then we have the OSI reference model, and OSI is open systems interconnection. So the idea of this is to ensure that devices from different manufacturers can communicate. Today, you don't end up buying a Samsung phone and you're calling someone who is owning a Techno phone, and then you realize that Samsung cannot call Techno. It's not possible to come across such a scenario, because whether you are Techno, whether you are Samsung, or even any other model, the devices should be able to communicate together. The features of those devices could be very different. For example, maybe a Samsung phone could have additional security. It could also have maybe other features, maybe smart writing, where you can use maybe like something like a pen, or use your own handwriting to write on the screen, and it's converted to text and sent via email or via text messaging. Those are features that are implemented in those high-end devices. But the most basic functionality of a phone is to be able to make a call from one device to the other. So there's the minimum implementation that must be there in every device that is called a phone, that it should be capable of receiving a call and being able to send, should be capable of receiving a text message from whichever device and being able to send. So what ensures that is what you call the open system interconnection model, the OSI. We are referring to what are the principles that every manufacturer must be able to implement to ensure that the system that they are, or the device that they are manufacturing is an open system when it comes to connection or being able to add functionality to that particular device. So those are major topics that will be coming up. We'll be looking at in the lessons to come. Now, for the purpose of today's presentation, I want to talk about LAN design and wide area network design. So now, the notes that I've shared under topic 3, is a full document from Cisco on the different types of network designs that you can implement. And the major purpose of following those particular models is to be able to achieve what we are going to call the bare minimum. Now, when you are designing a network, what are some of the things that you want to achieve in a network? One of the things is that your network should be easily expandable. You do not want to design a network today for maybe 5 people because your office has 5 staff, and then maybe 1 year later you experience exponential growth, and now your company is employing 100 people, and you need again to overhaul your network and start designing another network for 100 people. You do want a scenario where your network is able to grow depending with the demands and usage, and it's not going to be overwhelmed. You want a scenario where your network is capable of being expanded to accommodate a much bigger number of people or user needs. The other thing that we'll be looking at when you're designing a network is how simple is your network going to be. Because the more complex your network design, the more difficult it's going to be for you to troubleshoot your network. So you'd want a scenario where if there's a failure in the network, at least you are able to use the shortest time possible to be able to detect where the failure has occurred in your network. You do also want a scenario where there is stability. If there's a natural calamity, like maybe fire, flood, or earthquakes and such, or even traffic that has never been experienced before in the organization, you'd want a scenario where your network is able to withstand that and to recover from the kind of failure that your network can experience temporarily. And the other thing for organizations is this: anytime you are called upon to design a network for an organization, there is what you have in mind, what I'm going to call the dream network. Yeah? A network that would dream of, you'd want an organization to have. But you also have to be cognizant of the fact that organizations do not have a lot of money. When they want a network is because they want to facilitate business. So when you're designing this network, you have to consider what is the cost. What is the cost of installing this network? Is it going to be cost effective? And at the same time, are you still going to ensure that standards are maintained? So going for something cheap does not necessarily mean that it cannot do the purpose that is intended to do. For example, if you say that you want to go and shop for a phone, you'll say that I have maybe something like a budget of 10,000 shillings. Now, 10,000 shillings is a moderate phone. You'll not say that because I only have 10,000 shillings, I just go pick any phone that is meant for, that is retailing at 10,000 shillings. There are still things that we'll be looking at. You say that I want a phone. Why do you need a phone? Maybe I need a phone to be able to access my online classes. So one of the requirements in your phone will be, does it have the necessary amount of memory for you to be able to maybe interact or engage online in an online activity? You'll also be looking at, is it capable of downloading multimedia content? For example, we know that very soon most of you will be doing exams online, and we expect that either you'll be using a phone or you'll be using a laptop to be able to do the exam. So the question you'll be asking yourself is your phone capable of being able to handle that you are doing an exam probably offline, you'd want to upload to the site for the lecturer to mark. You'd also want to interact with a real-time environment where you are asked questions and you pick the correct answer and you click on next. And I'm sure some of you have done the Cisco exams under the CCNA 1, 2, 3, and you have seen some of those exams where at some point you are required to do what is called drag and drop. You're supposed to maybe to pick a multiple choice question, or even expected maybe to pick 2, 3, 4 correct answers. So when you're going for that, when you're shopping for your phone, obviously you'll be looking at the capability. As much as you do not have a lot of money to buy the phone, you'll also be looking at does a device that I'm going to get meet the standards that I'm looking for? So it's the same thing when it comes to network design, that as much as you're looking at the organization budget, you should also ensure that whatever design that you come up with is going to fit the budget without compromising performance. Okay, so the question is, what are the design considerations that you'll be looking at when you're designing a network? Now, if I just summarize the document that I've shared under the notes, the reason why I'm not sharing it on this live session is because of the size of the document. So the document is 27 pages, and it's going to give me a lot of problems when I'm scrolling in this live session. But I want to summarize some of the things to get from that particular document. One of them is, what are the LAN design principles? So if you have a document somewhere opened on your laptop or on your device, so one of the things that I want you to get from that document is the LAN design principles. And there's a statement that reads that any successful design or a system is based on the foundation of a solid design theory and principles. So even before you start touching cables and the switches, you need to have in mind the design theories that exist and the principles that you have to take into consideration when you're designing these networks. So now that this document that has been shared is a recommendation from Cisco about community college LAN design consideration. And when talk of a community college, is not like maybe a small college that you'll find in a village. According to the Cisco community, what they mean by community college LAN design considerations, they are looking at a scenario of either this particular college is in one building. There's also a possibility that the college has branches across a city or across a country. So in that case, they would need to be connected to some WAN technologies for them to be able to link one site from another.
Right.
College is a campus. University of Green and Sciences, and I'm assuming that all those schools could be in separate buildings, but it is one university. So in that case, it's one network, and therefore, if it's internet access, all those buildings require internet access. If it is telephone services, all those buildings require telephone services. And in the case maybe there is collaboration, probably like one university of health science is collaborating with another university of health science, maybe on a joint research project. And a good example is like research on coronavirus and such, where you find that now scientists across the world try to collaborate their findings. You'll find that there are those who are testing maybe Ebola drugs. There are those who are testing, for example, in the US, the drug that they are trying to test and see whether it can cure coronavirus is hydroxychloroquine combined with zinc. You have also seen some other countries where they are trying to go the herbal way. Yeah, if I mention countries like Madagascar and others, Burundi and such, they still have a belief that probably the cure could also be found in, and now have scientists across the world trying to collaborate in various ways, various tests, and sharing their results. And it's a way of guiding their colleagues that if this particular route gives some positive indications, then it's like a guide to others that why don't you try this, because we think that this appears to be the way to go. So that's an example of collaboration. So when you're designing a network, you should have that in mind. Is it possible for a network to be accessed from another building? Is it possible for the network to be accessed from outside the building? Because we also have scenarios where we have marketers in an organization, and these marketers are required to be making sales. So these marketers will always be moving from one city to another doing sales, but at the same time, they need to connect back to their company network to be able to see any new updates, to be able to receive their emails and any information that is requested when they are out there. they should be able to access their corporate network using any of the technologies such as VPN. That's virtual private network. It's just one example where someone can connect to their corporate network and they can easily connect to their computer and extract information. So now from the document that I've shared, we have four major principles that have to be put into consideration while designing the network. And one of them is a hierarchical. And the hierarchical principle deals with facilitating understanding of the role of each network device at every layer, or we are going to call it tier. So I'm sure that most of you have been introduced to Cisco networking. And when you look at the hierarchical design of Cisco networks, we usually have three major layers in a network. And one of the layers is normally called the access layer. And the access layer is normally the layer that users in an organization use to be able to interact with each other. So in short, the access layer is like a switch that is connecting the different users into an organization. I'll just give an example of our school where the access layer could be the switch that is connecting the classes, the computers that are in our classrooms. So that will be an access layer switch where now all the users are connected and they are able to share information, or they are able to access files from one computer to the other. So that's the access layer switch. But again, you'll not find that in most of the scenarios, you'll not find it the case that the switch that is connecting computers in the class is the same switch that is accessing the internet. So that switch is just going to be an access layer where all the computers are interconnected. But the switch will be connected to another switch, and we can call that other switch maybe the distribution layer switch. And the distribution layer switch could be the switch that is interconnecting maybe the classrooms. So I want to look at a design of a school, and I'm giving the case of maybe Tech University, where we'll find that now there is one switch that is connecting classrooms. There will be another switch that will probably be connecting the staff network, and there could be also another switch that is probably connecting maybe the accounts and front office network. So why am I talking of like three different switches? Okay, it could be one switch, but most of the time can be implemented as three different switches. The reason is usually something to do with the networks. Organizations usually implement something that is called subnetting. And subnetting is just a process of dividing a large network into a smaller network or into smaller networks. And the idea of that is to minimize traffic. Like, for example, if you realize that there's usually a rule that is called the 80-20 rule. When you're designing a network, you have to look at that. It's called the 80/20 rule. What does that mean? So that rule is usually used also in business when people are doing marketing. It's also a principle in marketing, the 80-20 rule. Now, for example, in marketing, the 80-20 rule means that 80% of your sales will be coming from 20% of your customers. So if you are running a shop, maybe there are many people who normally come to your shop. You can say that you normally sell maybe items to, on average, you sell goods to maybe like 100 people. But from those 100 people, on average, there's a possibility that almost 80 of them are just people who are passing by and they happen to see your shop and they came and bought something and left. So as much as that thing they bought was good or bad, they might not have intentions of coming back to your shop just because maybe they were able to buy it from your shop. A good example is like maybe someone was passing and decided that I feel thirsty, so I need to buy a bottle of water. So just get into a shop and ask for a bottle of water. And once you're given the water, maybe you'll be asked which brand. You say, I want a Dasani brand. And you'll be given your Dasani brand and you go. That does not mean that anytime you need to buy a Dasani bottle, you'll always be going back to that shop. Because what you're just doing is you felt thirsty and you ended up buying water from that particular shop. But that does not necessarily mean that you'll always be going back to that shop to buy water. Now, the 80-20 rule would mean that only 20%, 20% of your customers will be repeat customers. So that 20% will be the group that makes your business to grow. The reason why we are saying it's the group that makes your business to grow, these are the people who keep on placing large orders. So you can have 20% of people who always buy in bulk. And then you have the 80% that always buy single items that cannot sustain your business. Now that's the 80-20 rule. So meaning that in marketing, you need to identify that 20% that makes your business to grow, because they normally buy goods in large quantities. And those are the ones that keep you going. And you have to treat them well to ensure that if you retain that big clientele, the 20%, you're sure that your business is going to continue thriving. Now, in networking, the 80-20 rule means this, that 80% of the traffic usually comes from devices that are in the same, that are close to each other, or devices that are in the same location. For example, like in a classroom, if maybe files are being shared, you're expecting that the interactions taking place are almost accessing the same resource, because maybe if it's a training scenario and the lecturer says that go to the file server, access this particular document, copy it on your desktop and open the document. So everyone in the classroom will go to the file server and ensure that the document is copied. If there's another instruction the next day, again, they'll do the same thing. So meaning that this file server is being accessed by almost like 20 computers in the same classroom. So you have to ensure that the file server and these 20 computers are in the same network. Then if we have maybe that file server hosting some resources that could be required by maybe another department, the possibility of that happening is usually maybe like 20%. So you'd find that if you are able to identify 80% of traffic accessing a particular resource, then you have to ensure that that resource and the 80% traffic are in the same network. And then now you only allow for the 20% for maybe remote access from other different networks. So now I have mentioned 4 considerations that we'll be looking at when you're designing a network. And one of them is you want your network to be able to expand in future. You want your network to be simple. You want your network to be able to withstand future shocks, for example, major disasters, and you should be able to recover. And you also want your network to be not to be consuming a lot of financial resources when it comes to the organizational finances, because why you need a network is to be able to facilitate business. So the core activity for most organizations is making money, business. So what the network does is just facilitating business. So it should not be the case that the cost of having a network is more than the revenue that you're getting, that the cost of the network is more than the profits. You want the other way around, that the network is not consuming a lot of money, but at the same time, the network is able to maintain performance. That performance is standard and the network is easily accessible and the flow of everything is up to the required or the designed. There's usually what is called the KPI when it comes to, for example, like if a company maybe is outsourcing internet, we usually have some policies that are normally put in place. For example, like if I want internet connection from Safaricom, before I sign a contract with them, they have to give me what is called the KPI. That is the key performance indicators, that if I see 1, 2, 3, 4 happening, I should be able to know that my network is okay. We also have what they call MTBF. That is the mean time between failure. It's like a standard, a standard of service delivery. Mean time between failure. That in case the network fails, because they are my service providers, within what period of time should I expect them to restore the network back to normal? Because you cannot assume that the network will never fail. At some point, it's going to fail. But how much time should I wait before I see normalcy being restored? That's what is called mean time between failure. That if it goes beyond a certain threshold, like if they tell me that if your network fails, we are going to make sure it's up and running within 30 minutes. So if it goes beyond 30 minutes, I can terminate their contract because they have gone against the terms and conditions of the particular contract. So now, those considerations that I've mentioned, one is scalability. So those are the key terms that I want you to get from the notes. One is scalability, and scalability is the ability of a network to expand in future, or when there's increased demand, the ability of the network to respond to the increased demand. So that is scalability. I repeat again, scalability is the ability of a network to expand easily without overhauling the infrastructure. Because you cannot say that now that we have visitors, maybe to our environment, it could be like or maybe a conference that is bringing together all students. Usually you are normally in different classes learning different lessons, but maybe there's an event that requires all the students to be in the same hall, the same lecture hall, maybe to listen to a lecture, maybe a conference for 1 week. We do not expect that because now we are bringing together 1,000 students that we have to overhaul the network. Tuanze kung'oa cables so that we can put infrastructure that will meet 1,000 people. Our network should be such that it can support 3 people, 5 people, and if there's a need to have 1,000 people in the same room, the network should still be able to support that. So that's what we mean by scalability. Simplicity is the other thing that I mentioned, and simplicity is just the idea of troubleshooting, that in case your network fails, it should be easy for you to be able to troubleshoot and to know where the failure occurred and to restore normalcy. Then resilience from the word resilient. So resilience is the ability of your network to recover during abnormal network failures. The ability of your network to recover during abnormal network failures. That is resilience. And then the fourth consideration is cost effectiveness. Cost effectiveness means that your network should fit the budget or what has been budgeted for without compromising performance. So those are 4 considerations before you even touch anything. That scalability, will it be capable of expanding? Simplicity, how easy is it to troubleshoot your network? Resilience, that is, can it recover from failure? For example, if you use resilience in our context today, we'll say that our country has suffered economically because of the virus. And resilience is, are we able to bounce back to the normal situation, maybe in a month's time or in 2 months' time, and we still continue being the same people without having, because there are many things happening where people are losing income and all that. The economy businesses are crumbling, and maybe even some of the schools are not going to recover after this based on the cash flows that they were experiencing and probably the contracts they had with suppliers and such. But resilience is how quickly can your network recover after a major disaster. So that is resilience. If there's an abnormal failure, how quickly are you able to recover from that and continue normal operation? And then we have said cost effectiveness is something should be able to fit the budget without compromising performance. So those are 4 major considerations: scalability, simplicity, resilience, and cost effectiveness. So as a part of your assignment, I want you to research on the different LAN technologies that exist. So the different LAN technologies. LAN is LAN, local area network technologies. You can note that down. So I want you to research on the different LAN technologies that exist. And the other thing is the different WAN technologies that exist. And the one is the wide area network. Today, if an organization wants access to internet, they are going to use one of the wide area network technologies that exist. So I wanted to highlight them. What are the technologies that are used under the WAN networks? So just call them. You can Google WAN technologies, and you're going to find maybe examples like frame relay. That is one. Maybe you'll come across something like synchronous optical networks and such. I want you to research on WAN technologies that exist, and you should be able to at least define each of them, and LAN technologies. Now, if you also look at the shared notes, there will be diagrams that you'll see. So I want you to be able to understand from that diagram from Cisco. So there's one model, there's one network model that is called the hierarchical network model. The hierarchical network model is the model that is usually employed in all the major networks, and it is a recommendation from Cisco that when you're designing a network, you should at least try to use the hierarchical network model. So some companies will go for what is called the two-tier architecture or the two-tier model, and we also have the three-tier model. Now, if you go with the three-tier model, which is usually recommended, is that when you're having switches connecting a network in an organization, you'd want a scenario where those switches are divided into 3 layers. So you have the access layer that is connecting all the computing devices in an organization. The access layer is used by users and portable devices to be able to connect to the network. All desktops, laptops, smartphones, telephone lines are usually connected to the access layer, but the access layer is being connected also to another layer above it, and this layer is called the distribution layer. And the distribution layer is the one that provides for things like breaking what is called the broadcast traffic. Now, broadcast traffic is where like a machine wants an IP address. Maybe you've connected a new computer to the network. So that computer wants an IP address, and it starts sending packets, which are called DHCP discover messages. So it's sending maybe the DHCP discover messages to the server, asking where is the DHCP server to provide me with an IP address. So that message is usually broadcasted to almost all machines in the network. Now, when you have those packets going all over the network, like let's say it's just a machine that is in the classrooms, asking for an IP address from the DHCP server, you do not want those packets to travel in the entire network. They've gone to the administration department, they have gone to other schools, hospitality, business, ICT and engineering. You do not wish all those machines to keep on seeing those DHCP discover messages. You'd want at some point to break the traffic such that only a select number of machines will be able to be disturbed by these DHCP discover messages, and it's not going to put a lot of weight on the bandwidth of the organization. So there's what is called broadcast traffic. Broadcast traffic is where a machine is sending messages to all the machines. If you have 1,000 machines and one computer wants an IP address, it sends messages to all the 1,000 machines. And then you end up having another 20 machines that are asking for IP address, and they also send the messages. you'll end up with a lot of traffic on your network, which is not meaningful. So you'll find that maybe people are not able to access internet properly because the network appears to be busy. People are not able maybe to work. Maybe they are having a live conference using technology such as Zoom and such. Most of this traffic will be distorted by the overloaded traffic that is not necessary in the organization. So you have to ensure that you keep that at a minimum. So some switches are designed in a way that they break that once the traffic gets to the distribution distribution switch, it's not going to be escalated to the other switch. It's just going to be stopped from there. And if the machine needs maybe an IP address, is going to be redirected to the server that is going to provide the IP address. And then now we have the core layer. And the core layer is the layer that provides the backbone to the network. Now, if you look at the diagrams of the shared document, there are several scenarios. Like you'll come across figure 1 in page 1 of a building that is so it's just a design for a medium building, small building, an extra small building, and also the LAN building. Now, if you scroll down through the notes, I would want you to look at a diagram that has a core layer as the backbone that is integrating. I'm looking at an example of a school, maybe a university that has branches across the city. So maybe there is Zitech University, Ruiru campus, there is Zitech University, Pioneer, Standbank, Agriculture House. So those are like 4 buildings or 4 sites. We are looking at a scenario where if there is a file server in Ruiru campus, it should be accessible from any of the campuses. But you realize that Ruiru and town and other campuses there's a distance between those two buildings. So do not expect a scenario where there will be a cable running from Ruiru to Pioneer campus. So the organization is not going to do that. They're going to make use of the wide area network technologies, maybe connecting to a fiber network that connects to the internet. And they'll ensure that the server that is at the core layer is able to connect those several buildings. That if there's a request from one building to the other, so it has to go through the core layer and to the other building. So the core layer will be responsible for providing the one connection. It will also be responsible for providing the security requirements. For example, like if it's VPN access, you'd want traffic or information that is being accessed to be passed through the internet, but in a secure way. So VPN is a technology where you create a secure tunnel that data or traffic can flow from one particular network to another through the public internet, but there is a tunnel, a private tunnel that is created such that any other computers on the internet may not be able to see that kind of traffic. So it's just a way of segmenting the network to ensure that the core layer deals with the backbone, the distribution layer deals with the distribution of the network from one building to the other, and the access layer deals with the access devices, the end user devices, computers, laptops, desktops, phones, connecting to the network. They'll be connecting to the access switch. So that is what will be providing that is what will be handling the major traffic in the user departments. But if it's distributing the network, that is coming from the distribution layer, such that if there's a problem with network access, troubleshooting becomes very easy, and you achieve one of the considerations of simplicity. That if computers in one room cannot access the network, the only question you'll ask is, can computers in the other room access the network? If computers in the next room can access the network, then you're able to narrow down into this room that has failed, and you can tell that it's just the switch in that room that is failing. But if computers in one room cannot access the network, you go to the next room, they cannot access the network, and the other room, and you know that all these rooms are connected to the distribution switch, then you can easily narrow down and say that the problem is with the distribution switch. Now, if computers from one network, maybe one room, can access the other room, and you know that each switch in every room is connected to the distribution room, so that tells you that the distribution switch is working because computers from one room can access the other room. But now if these computers cannot access the internet, but they can access each other, it means that the access layer switches are okay, the distribution layer switches are okay, but the core layer switches have a problem, and probably it's a backbone problem between the core switch and the distribution switch, or it is an internet problem from the core switch maybe to the internet service provider. And that is what we mean by simplicity. The hierarchical model provides a layer of simplicity to ensure that you are able to know at which level should you embark on the troubleshooting process. So now the other design principle that I want you to be keen on is something called modularity. So the other design principle that I want you to be keen on is what we are going to call the modularity. And modularity is the concept of implementing a network on a modular basis. Now, a module, you can think of a module as maybe a service that is going to be provided in a network. Like today, if you are designing a website, maybe the first thing you'll be looking at is you want people to access the company through the website. So what you are creating is the first module, that is the homepage or the landing page, that when people access your website, they're able to see about us, our products and such, and maybe contact information where they can make calls. But maybe with the time, you'd want a scenario where you do not want maybe users to be queuing in your office. You do not want users to be traveling to your office to come and ask simple questions. So maybe you can implement a module of contact us page, maybe something like a form, such that if they just go to that page, maybe the page is called Talk to Us. So when people go to that page, they enter their name, their address, their question, they click submit. And now the server admin is able to go to the database and check what has been submitted, and they get back to the customer if it maybe within a particular period of time to respond to the inquiry. Okay. After some time, you realize that you have become popular. Your company has become popular, and you want people to be shopping online. So they just purchase everything online. They click on an item, they see the price, they enter their location, they make payments via maybe mobile money transfer, and finally what they're expecting is delivery, still from the website. So they click on an item, they add to cart, they confirm payment, then you receive that information and you deliver. So now that website is made up of 3 modules. So one of the module is the basic information. The other module is the idea of people interacting with the website and that information being sent to a database. So you have the database module, and then you now have the idea of people making online payments, and they get a confirmation, and now they wait for the delivery of goods. So now modularity network design, it's the idea of allowing the networks to grow on an on-demand basis. That today your network supports 10 people, but if tomorrow your network wants to support 30 people, it's possible for your network to grow, to expand to the level where you can support 30 people. And in case there's need for 50 people, you know what to do. Maybe all you have to do is just to bring an extra switch, and that switch will now connect to the other 20 people, and now your network can support 50 people. And then resilience is what I mentioned previously. Resilient is the ability of your network to satisfy the user expectations and the network to be always on, such that if it fails, the network knows how to recover. And the other design principle is flexibility, that your network should be able to allow intelligent traffic load to pass from one network resource, one network to another. Now, flexibility is this. We're introducing switches that are blocking broadcast traffic, that you want computers not to be going through so many layers. You want all the computers maybe to be communicating through the bottom layers and not to go up to the backbone for maybe traffic such as requesting for IP addresses, DNS servers, and such. You only want traffic going outside the network to go through those three layers. Like if someone is accessing internet, so that will mean that it has to go through the access switch, the distribution switch, the core switch, and out to the internet. So that's the only thing that you want to go through those three layers. But the local area network communication, you'd want all that to be handled at the lower level. So that is what we mean by flexibility, that we are allowing intelligent traffic to pass through, but not all traffic. So most of the devices, for example, routers, have a way of implementing what is called access control, that packets are allowed to pass through the routers based on whether they meet specific conditions. So I do not want to go into the details of the document. Like I said, it's a large document. I want to give you time to go through that document. But what I'm interested with is in that document, the document, I've shared the document because of the diagrams. So that's the major reason why I've shared the document. The diagrams that are in that document and the explanation and the scenario 1, 2, 3, 4 of designing networks. So that again, I said, it's a recommendation from, it's an extract from the Cisco website. But what I want you to are design papers, the ones that design about resiliency and flexibility. The thing that I want you to get from the notes is what is the role of the access layer, what is the role of the distribution layer, and what is the role of the core layer. If you're able to get that, that's going to be covered. So I want you to remember the small assignment that I've given you, that research on one technologies, list what are the different one technologies that exist, what are the different LAN technologies that exist. And the other thing that I want you to do is this. I want you to go to the internet and download the Cisco Packet Tracer. So if you have it, well and good. But I want you to go to the internet. In case you don't have it, download the Cisco Packet Tracer application. In the next lesson, I'm going to give you an activity to perform using the Cisco Packet Tracer application. So it's the whole idea of ensuring that the device that you are using is able to do something practical in nature. That when you are using Packet Tracer, we should be able to have like 2-3 computers connected together, and we should be able to do some activities like testing whether the machines can communicate with each other, and other practical activities that we can do with the Packet Tracer. Maybe how packets move from one device to the other. So I want you to do that. So download the Cisco Packet Tracer application. So thank you for being in this particular session. So what I want you to do right now is for the remaining 40 minutes, I would want you to go through the lecture notes and try to read and have a deeper understanding of the LAN design principles as recommended by Cisco, being one of the major companies that deals with the networking. Thank you. So in case you have any question, you can type on the public chat, then I can respond before I terminate the live session. So anyone with a question or reaction, you type on the public chat right now before I terminate the session. Anyone who wants to type something on the public chat, you can type it right now before I terminate the session. In case you have type a reaction, comment, question, you can type on the public chat before I terminate the session. Okay, so thank you for being present in the session. So again, I want to stress something on class attendance. So our rules still apply that you must have attended 80% of your lectures, because the system that we are using is taking statistics. So I'm just telling you at an I'm just telling you that because I don't want you to be caught up with the issues that might arise. The system that you are using is logging on your attendance automatically. If you log into the session, the system is automatically taking your attendance. So ensure that you always log into the session whenever you're having classes. That will ensure that you've met the 80% rule of your class attendance. So you have a nice time. So I expect that all of you are now moving to the lecture notes. I'm not going to post a discussion forum. I just want all of you to go through the lecture notes and try to read and understand the lecture notes as I have explained. Thank you.